So on Friday we learned 6.8. Today we're going to learn 7.1, so we're starting chapter 7. I'm going to go ahead and give you the answers to the 6.8 practice, just so you have those. If you don't want to get up and look in the teacher's book, here are those so you can check your work. And then we're going to go ahead and jump into 7.1 notes. So you can pause right here if you want to keep checking your work, or if you're ready to take notes, let's just go ahead and do that. So we're going to be solving quadratic equations today, and we've done that by factoring before, but now we're going to do it a little bit different way, and it's called completing the square. Sometimes you don't have to complete the square, but when you do complete the square, you're going to have an equation that's like the one we're about to solve right now. So with this equation right here, you have the left side, which is squared, and the other side's not. So we know how to undo something that's squared. We square root both sides. When we do that, we know the squared thing cancels, and we're left with this. When I square root both sides, that's going to give me an ugly decimal, and I don't really want to mess with that. So if you just write plus or minus the square root of 5, you're covering all your bases. You're totally fine. I'd encourage you to just leave it like that. X is almost by itself. All we have to do is subtract 3 from both sides. We can't actually subtract 3 from a radical, so all you do is write -3 plus or minus the square root of 5. And those are actually just your two answers right here, which is so nice. Makes it easy. The second problem is very similar, just a smidge different. I know your gut instinct would be to add 2 to both sides, but if you add 2 over here, this gets you x squared minus 4x plus 6. And there's nothing that multiplies to give you 6 that's going to add to give you a -4. That doesn't exist. So what we're going to do instead is I'm going to get rid of all of this. Oops, I want to redo. Okay, what I want to do instead is I want to factor the left side. If we factor it, you get x minus 2 quantity squared. Okay, and now I have a problem just like the one we did where you can square root both sides. And here we end up with x minus 2 is equal to plus or minus the square root of -2. You know we can't have a negative underneath the radical, so I'm going to go ahead and take it out. We have plus or minus I square roots of 2. And last but not least, if you just add 2 to both sides, you end up with x is equal to 2 plus or minus I square roots of 2. And that's another way to solve quadratic equations. This form's really nice. It's really easy. So what if you have an equation that's not set up like that, where you can't immediately factor it and then square root both sides? There's something you can do every single time to make it so that you can then square root both sides and solve really easily. And that's called completing the square. That's what I'm going to teach you how to do. So the first thing you have to do is get the two variables totally by themselves on one side of your equal sign. So you're going to subtract 3 from both sides. And we end up with a squared minus 5a. You're going to leave some room, and you're going to write equals -3. Because what you're about to do is complete the square. You're going to add something to both sides of your equal sign so that you can factor the left side into something that is a square. So you take this term, you're going to take -5, and what you do to that -5, I just pulled that from here, it didn't come out of nowhere. It's always the term in front of the letter that's by itself. So what you do to this guy is you have to divide it by 2 and then square it. So that gives you -5 squared is 25, and 2 squared is 4. This is what you add to both sides, which seems really weird, I know. Okay, but when you do that, what you've created on the left side is a perfect square trinomial. That means if we were to factor this, you get a minus 5 over 2 quantity squared. And on the other side, when you add those two things together, you end up with 13 all over 4. So think about it. If I took a minus 5 over 2 times a minus 5 over 2, and I FOILed it, I'd get a squared. I'd get negative 5 over 2a minus 5 over 2a plus 25 all over 4. Well, 2 negative 5 over 2a's, those become negative 10 over 2, which is the same as negative 5. There's that negative 5 right here, and then that 25 over 4 is right here. Now, I don't expect you to factor every single time. There's actually a trick to know what it's going to factor to become. I don't know if you noticed it, but right before you square both sides, or right before you square this guy, so when you take the number, you divide it by 2, that's actually what your factor is going to become right here. But you have to go ahead and square it, because this is what you add to the right side of your equation. Okay? I'm going to go ahead and keep going. I think if I do another example, it'll make more sense, but I want to go ahead and solve this guy. We're going to square root both sides, and you end up with a minus 5 over 2 is equal to plus or minus the square root of 13 is on top, and we know that the square root of 4 is 2. I'm going to go ahead and add 5 halves to both sides. And so your final answer for this is actually a is equal to 5 over 2 plus or minus the square root of 13, oopsies, the square root of 13 all over 2. Kind of confusing. Let me do one more and we'll see if it makes a little bit more sense. Okay, so this one's a little bit more difficult. So the first thing we have to do is we have to get the two things that have variables on by themselves. So you would subtract 3 from both sides. So I end up with 7x squared minus 8x, and it equals negative 3. Now the evil thing about completing the square, you can't complete the square if there's a number in front of x squared. So before we can complete the square, we have to divide everything by 7. Okay? So really what we're doing is we have x squared minus 8/7 x, and we're going to complete the square is equal to negative 3 over 7. That's the square that we're going to complete. I needed some more room, so here's what we're going to complete. We're going to complete the square. We have to figure out what our factor term is going to be and then what we have to add to both sides. So I have to take negative 8/7, and remember you have to divide it by 2. So I might actually do that first, because that really means I'm multiplying by 1/2. So times 1/2. And so you get negative 8 all over 14. Oh my gosh. Which is the same as, if I divide both those by 2, I get negative 4 over 7. So that's what you're going to square to figure out what you're adding to both sides. So when I square this, I end up with 16 all over 49. So that's what you're adding to both sides. 16 all over 49 plus 16 all over 49. Okay? So remember, there's a trick to figuring out this side. If you just look and see what was this before I squared it, that's what your left side's going to become. X minus 4/7 quantity squared. And then I want to add these two guys together. In order to add them together, I need common denominators. If you multiply them both by 7, this becomes 49. And this becomes negative 21. So negative 21 plus 16 gives you negative 5 all over 49. Whew, this problem's tricky. So now what you need to do is you can square root both sides. Okay? And over here we end up with x minus 4/7, and it's equal to plus or minus. If you square root negative 5, an I comes out, and the 5's got to stay underneath, and the square root of 49 is 7. Now we're going to add 4/7 to both sides. So there's two ways to write this answer. I showed you one way in the previous problem. You can also write the answers as, since they both have a denominator of 7, he can go on the bottom. And on the top you can have 4 plus or minus I square roots of 5. Once you practice this a couple of times, I think it'll click. It's just weird at first, you kind of forget the steps. But just look at the examples, look at how you did it, the steps that you did, and I think you'll be able to figure it out. Good luck.